Solution of non-homogeneous differential equation using method of undetermined coefficient. In this video, we are going to learn how to find the solution with the help of this method. This method is already explained in a previous video where we have observed how to find the particular form, or we can say the trial form of particular integral by observing the non-homogeneous function. So let's understand how to apply this method in order to find the general solution of a differential equation. So we have this question. So we need to find the general solution of this differential equation. So very first we will write its operator form, and its operator form is this. Then we will collect the coefficient of y. So after that we will have this form on the left hand side, and the right hand side function is as it is. Write the auxiliary equation, means replace d by m and y by 1. So we have this auxiliary equation over here. Find its roots. Roots are 3 and 3, and the complementary solution can be written in this form. Because both the roots are same and real, therefore we are multiplying x over here. Observe the non-homogeneous function. So according to this, the particular integral is of the form a times of e raised to power 2x. Now we need to check whether we need to multiply by x, x square, or any term of x for this case. So for that we will check whether this term is the part of complementary solution. So no, because in this case it is e raised to power 3x, again it has e raised to power 3x. So they are the entirely different terms, therefore there is no need to multiply by x. So for finding the constant value, what we need to do, we need to substitute this solution over here. So for that we need a first order derivative and its second order derivative. So find its first order derivative. Its first order derivative is equal to 2 times of a e raised to power 2x, and its second order derivative is equal to 4 times of a e raised to power 2x. Substitute these values over here. So second order derivative minus 6 times of first order derivative plus 9y is equal to e raised to power 2x. We need this form. So we substitute these values over here. Second order derivative is 4a e raised to power 2x minus 6 times of first order derivative, that is 2a e raised to power 2x, plus 9y, that is the trial form of particular integral, a times of e raised to power 2x. So this must be is equal to e raised to power 2x. Simplify this. So if you simplify this, or we can say collect the terms of e raised to power 2x, so we have 4a minus 12a plus 9a into e raised to power 2x is equal to e raised to power 2x. So from this side, we have the coefficient of e raised to power 2x as this, and on the right hand side, the coefficient of e raised to power 2x is 1. So we can say that this term is equal to 1. The simplified form of this term is equal to a, that is 4 minus 12 plus 9a. So this term must be is equal to 1. So that is only possible when the value of a is equal to 1. So it means the particular integral in this case is e raised to power 2x after substituting the value of a. And finally, the general solution is equal to complementary solution plus particular integral, that is equal to c1 e raised to power 3x plus c2 x e raised to power 3x plus particular integral is e raised to power 2x. And that is the final answer by using the method of undetermined coefficient. Let's take another example. So in this case, first we will write its operator form. So its operator form is d square y, no derivative of y. So this y is as it is equal to x square. Collect the coefficient of y. We have d square plus 1 into y is equal to x square. auxiliary equation is m square plus 1 is equal to 0. Now, what are the roots of m? That is plus minus iota. So, in this case, we have the answer in form of exponential cos and sine. So, final complementary solution in this case is e raised to power 0x because real part is 0 into c1 cos of x plus c2 sine of x. So we need to find the particular integral by using method of undetermined coefficient. So on right hand side, that is non-homogeneous function is a polynomial. So in this case, the particular integral we assumed as a times of x square plus b times of x plus c, where a, b, c we need to determine and they are the constant. Now we need to check whether we need to multiply by x, whether any term over here is repeating here. No. So there's no need to multiply by x. Now we need to substitute this solution over here. So we need its second order derivative. The first order derivative is equal to 2 of a into x plus b. Its second order derivative is simply 2 into a. Substitute these values over here. So we have second order derivative plus y is equal to x square. Second order derivative is 2a plus y is this one. This is ax square plus bx plus c. This must be is equal to x square. So from here again compare the coefficients. So what are the coefficients of x square? So that is the a. And on the right hand side it is a 1. So the value of a is equal to 1. What is the coefficient of x in this case? That is the b. On right hand side it is a 0. That is the coefficient of x. Now what are the constant terms on the left hand side? That is the 2a plus c. This term plus this one. On right hand side it is a 0. Now from here this is the comparison of the constant terms. So from here we can extract the value of c. So c is equal to minus twice of a. And the value of a is 1. So the value of c is equal to minus 2. So final particular integral in this case is a is 1. So we have x square. B is 0. So this term is getting 0 plus c is minus 2. So final particular integral in this case is x square minus 2. The general solution yx is equal to ycx plus ypx. That is this plus this form. Let's try to answer the next question. So in this case, the operator form is d square y minus 5dy plus 6y is equal to sine x. So collect the coefficient of y. So we have d square minus 5d plus 6 into y is equal to sine of x. So let's find first its complementary solution. For that, write the auxiliary equation. That is m square minus 5m plus 6 is equal to 0. So roots in this case is equal to 3 and 2. Final complementary solution is equal to c1 e raised to power 3x plus c2 e raised to power 2x because the roots are real and they are different. For the non-homogeneous function, that is the sine x, the particular integral is of the form some constant into sine of x plus some constant into cos of x. So we need to determine the values of a and b in this case. So find its first order derivative with respect to x. So derivative of sine is cos and the derivative of cos is minus sine. Take its second order derivative. So second order derivative is minus a times of sine x, and the derivative of sine is positive cos but negative sine is as it is. Substitute these values over here. So second order derivative is minus a sine x minus b cos of x minus 5 times of first order derivative, that is a cos of x minus b sine of x plus 6 times of y, that is a sine x plus b cos of x. So this must be is equal to sine x. So let's simplify the left hand side first. So in this case, what are the coefficient of sine x? So sine x coefficients are minus a. This is minus 5 minus b, that is the plus 5b. In this case, plus 6a plus cos of x. What are the coefficient of cos? That is minus b, minus 5 into a, and over here 6 into b. So this is equal to sine of x. Now compare the coefficient. So in this case, sine x coefficient is minus a plus 5b plus 6a, that is 5a plus 5b. That is the coefficient of sine x. What is the coefficient of sine x in this case? That is the 1. So this is the first equation we are getting in this case. From here, the coefficient of cos is minus 5a plus 5b. In this case, the coefficient of cos is 0. So from here, if you observe, a is equal to b. Substitute a is equal to b in this case. So from here, we have a is equal to 1 by 10. And when you substitute over here, we are getting the value of b is equal to 1 by 10. So finally, the particular integral in this case is a times of sine x plus b times of cos x is equal to 1 by 10 into sine x plus cos of x.